Welcome to our channel. Today we're diving into some of the most revolutionary scientific theories that have shaped our understanding of the universe. From the tiniest particles to the vast expanse of space, these groundbreaking ideas have challenged our perceptions and opened up new frontiers of knowledge. Get ready to have your mind blown wide open as we explore the mind-bending concepts that have revolutionized our understanding of the cosmos and our place within it. We're talking about the theories that have reshaped physics, astronomy, biology, and our entire worldview. Fasten your seatbelts because we're about to embark on an exhilarating journey through the wonders of science. Imagine the universe not as a rigid box, but as a flexible fabric, warped and curved by the presence of matter and energy. That's the essence of Einstein's general theory of relativity. Before Einstein, gravity was seen as a mysterious force acting at a distance. But Einstein revolutionized our understanding by proposing that gravity is not a force at all, but rather a curvature in the fabric of space-time itself. Picture a bowling ball placed on a trampoline. The ball's mass causes the trampoline to sag, creating a curvature around it. Now imagine rolling a marble across the trampoline. The marble's path will bend as it travels through the curved region around the bowling ball. That, my friends, is a simplified way to visualize how gravity works according to Einstein. Massive objects like stars and planets warp the space-time around them, influencing the motion of other objects, including light. One of the most mind-boggling predictions of general relativity is the existence of black holes, regions of space-time, where gravity is so strong that nothing, not even light, can escape. These cosmic monsters are born from the death throes of massive stars, and their bizarre properties continue to fascinate scientists today. But general relativity doesn't stop there. It also predicts the existence of gravitational waves, ripples in space-time caused by the acceleration of massive objects. These waves were directly detected for the first time in 2015, a century after Einstein's prediction, confirming yet another aspect of his groundbreaking theory. Einstein's theory of relativity didn't just change our understanding of gravity. It revolutionized our concepts of space, time, and the universe itself. It showed us that the universe is a far stranger and more wonderful place than we could have ever imagined. Hold on tight as we venture into the bizarre and counterintuitive world of quantum mechanics. This theory, developed in the early 20th century, governs the behavior of matter and energy at the atomic and subatomic levels. Here, the familiar laws of classical physics break down, and particles like electrons and photons exhibit wave-particle duality, meaning they can behave like both waves and particles depending on how we observe them. It's like a tiny coin that can be both heads and tails at the same time, until we flip it. Another mind-bending concept in quantum mechanics is superposition. This principle suggests that a particle can exist in multiple states at once until it is measured. Imagine a single atom being in multiple places simultaneously. And if that wasn't strange enough, there's Heisenberg's uncertainty principle, which states that we can never know both the position and momentum of a particle with perfect accuracy. The more precisely we measure one, the less we know about the other. It's like trying to nail down a shadow. The act of observing it changes its behavior. Quantum mechanics has had a profound impact on our understanding of the universe, leading to the development of technologies like lasers, transistors, and nuclear energy. It's also essential for understanding phenomena like radioactivity, chemical bonding, and the behavior of stars. Despite its successes, quantum mechanics remains one of the most mysterious and debated theories in science, with interpretations that continue to challenge our intuitions about the nature of reality. Prepare to have your mind truly stretched as we delve into the enigmatic realm of string theory. This theoretical framework seeks to unify all the fundamental forces of nature, including gravity, which has long been a thorn in the side of physicists. Imagine a world where the fundamental building blocks of matter are not point-like particles, but tiny vibrating strings. These strings are far smaller than anything we can currently observe, and their different vibrational modes are thought to give rise to the various fundamental particles we see in the universe. Think of a guitar string. Depending on how it vibrates, it can produce different musical notes. Similarly, in string theory, the different vibrations of these fundamental strings are thought to correspond to different particles like electrons, quarks, and even gravitons, the hypothetical particles that mediate the force of gravity. String theory also suggests the existence of extra spatial dimensions beyond the three we experience in our everyday lives. These extra dimensions are thought to be curled up and hidden from view, much like a garden hose might appear as a one-dimensional line from a distance. While string theory is still highly speculative and lacks direct experimental evidence, it holds the potential to provide a unified description of all the fundamental forces and particles in the universe. If proven correct, it would revolutionize our understanding of the cosmos and our place within it. Get ready to journey back in time to the very beginning of our universe with the Big Bang Theory. This widely accepted model describes the evolution of the universe from an extremely hot, dense state to its present vast and expanding form. Imagine a cosmic explosion, not into space, but of space itself. About 13.8 billion years ago, our universe was an incredibly tiny, hot, and dense point. Then, it rapidly expanded and cooled, with energy converting into matter and antimatter. As the universe cooled further, elementary particles like quarks and electrons began to form. Over millions of years, gravity drew these particles together, forming the first stars and galaxies. The universe continued to expand and cool, eventually reaching the state we observe today. The Big Bang Theory is supported by a wealth of observational evidence, including the redshift of distant galaxies, the cosmic microwave background radiation, and the abundance of light elements in the universe. The cosmic microwave background radiation, a faint afterglow of the Big Bang, provides a snapshot of the universe just 380,000 years after its birth. By studying this radiation, scientists can learn about the early universe's composition and evolution. The Big Bang Theory doesn't explain everything, though. It leaves us with questions about what existed before the Big Bang, what caused it, and the nature of dark matter and dark energy, which make up the vast majority of the universe's mass-energy content. Get ready to explore the grand tapestry of life on Earth through the lens of evolution. This powerful theory, first proposed by Charles Darwin in the 19th century, explains the incredible diversity of life on our planet and how it has changed over billions of years. Imagine a world where species are not fixed, but constantly changing and adapting to their environment. That's the essence of evolution by natural selection, the driving force behind the diversity of life we see today. It starts with variation. Individuals within a population are not identical. They have slight differences in their traits. Some of these variations might give individuals a slight advantage in survival and reproduction. Those with advantageous traits are more likely to survive, reproduce, and pass on their genes to the next generation. Over many generations, these beneficial traits become more common in the population, while less advantageous traits become less common. This is natural selection at work, the survival of the fittest. Think of the classic example of giraffes. Giraffes with longer necks had an advantage in reaching leaves high up in trees, giving them better access to food. As a result, longer-necked giraffes were more likely to survive, reproduce, and pass on their genes, leading to the evolution of giraffes with even longer necks over time. Evolution is supported by a mountain of evidence from fossils, genetics, comparative anatomy, and biogeography. It's one of the most well-established theories in science and is essential for understanding the history of life on Earth, as well as the ongoing challenges facing biodiversity today. Prepare to be electrified as we unravel the mysteries of electromagnetism. This fundamental force governs the interactions between electrically charged particles, shaping our world in countless ways. Imagine a world where electricity and magnetism are not separate phenomena, but two sides of the same coin. That's the revolutionary insight of James Clerk Maxwell, who unified these forces into a single theory in the 19th century. Before Maxwell, electricity and magnetism were thought to be distinct forces. But Maxwell's equations showed that a changing electric field creates a magnetic field, and a changing magnetic field creates an electric field. This interplay between electricity and magnetism gives rise to electromagnetic waves, which travel at the speed of light. Think of light as a self-propagating wave of electric and magnetic fields, oscillating perpendicular to each other. These waves come in a wide range of wavelengths, from radio waves to microwaves, infrared radiation, visible light, ultraviolet radiation, X-rays, and gamma rays. Electromagnetism is responsible for a vast array of phenomena we encounter every day. It powers our homes, allows us to communicate wirelessly, and enables us to see the world around us. Without it, our modern world would be a very different place. From the smallest atoms to the largest galaxies, electromagnetism plays a fundamental role in shaping the universe we know and love. Thanks for watching. If you enjoyed this video, don't forget to like, share, and subscribe for more fascinating insights into the world of science. We've only just scratched the surface of these mind-blowing theories, and there's a whole universe of knowledge out there waiting to be explored. So stay curious, keep questioning, and never stop exploring the wonders of the cosmos. Remember, the universe is a vast and mysterious place, and every new discovery brings us one step closer to understanding our place within it.